Hello everyone, welcome to this session. Our chapter is motion in straight line. So far in our previous video, we discussed the couple of various things related to this topic. So today let's move on to the other subtopic. We'll be discussing about the acceleration. We'll start with the concept of this, the concept of acceleration. What do we mean acceleration? Acceleration, this is the rate of change of velocity. So that change of velocity may be from initial velocity to the final velocity. There's a change from being very slow to very fast. That is what we call the acceleration. It is the change in velocity per unit time. So we can simply say acceleration is the change in velocity per unit time, the amount of change of that kind of velocity at a given unit time, maybe seconds, that took to change that kind of velocity. It is obtained by dividing the change in velocity of a moving body to the time taken. So mathematically, you can obtain the acceleration by simply dividing the change in velocity to the time taken for that given kind of change. Acceleration is a vector quantity. A vector quantity is a quantity that has magnitude and direction. So acceleration, we say, is a vector quantity because it is obtained by taking the velocity upon time, whereby velocity also is the vector quantity. As velocity, it can be obtained by taking the displacement upon given time. So acceleration therefore is a vector quantity. Mathematically, you see here it is displayed acceleration is equal to change in velocity over time taken. You can see that this change is equal to final velocity minus initial velocity over time taken. So abbreviated as v minus u is equal to over t. That's the acceleration. Now let's move on to the velocity time graph. Velocity time graph, this is the graph that is drawn to represent the motion of a body. So this is the simple graph that is drawn just to show the motion or the movement of a body from one point to another. The velocity is represented by the vertical axis, while the time is represented by its horizontal axis. So there are two axes in the velocity time graph. There is vertical and the horizontal. The vertical one is the one that represents the velocity, and the horizontal one is the one that represents the time taken. Consider a body accelerating uniformly from rest to a certain velocity v within time t. This can be represented graphically as shown below. Here is our velocity time graph. So as we said, the velocity will be shown using the vertical axis, and the horizontal one will represent the time in seconds. So this is an example of a body moving from rest at 0 moving on to maybe 20 meter per second at 5 seconds. So this is an example of the velocity time graph. Now from there, in the above graph, the body attained a velocity of 80 meter per second within 2 seconds. As you can see here, the body attained 80 meter per second in 2 seconds. So this is an example. Also the same goes when it attained 4 in 1 second, 12 in 3, 16 in 4, and 20 meter per second in 5 seconds. So it also attained 16 meter per second in 4 seconds. Now it reached its final velocity, that is 20 meter per second at 5 seconds. The initial velocity was 0, that is the starting velocity, that was 0 meter per second. Now let's see the distance traveled. Distance covered by a body can be calculated from the velocity time graph by calculating the area covered under the curve or the graph. In this case, given the velocity time graph that we've seen, the area under the velocity time graph is always the area of the triangle. Now consider the shaded area, that is triangle OBC on the above graph, as we've seen the graph that is the velocity time graph. So from there you can obtain the distance. So distance traveled will be equal to the area of the triangle OBC, and you know that area of the triangle equals to half times height times base. So half times BC times OC. Now the height BC is the height BC represents the velocity attained, and the base OC represents the time taken. So BC, we know that is 12 meter per second, and the OB is 3 seconds. So from there you can substitute the values. We obtain the distance goes to a half times 12 meter per second times 3. So you get the answer, that is 18 meters. So the distance covered, considering that graph, is what we call that velocity time graph is 18 meter. Now let's talk about the acceleration. Acceleration also, it can be calculated from the graph by calculating the slope of the graph or the gradient of the graph. The slope of the velocity time graph is obtained as the ratio of the change in velocity to the respective change in time. Now here is how you can see it mathematically. Acceleration is equal to change in velocity over change in time. As you can see, so the final velocity minus the initial velocity over t2, that is the final time minus the initial time. Example, consider again the shaded region of our previous graph, in where the velocity changed from initial, that is 0 meter per second, to 4 to v, that is the final velocity, that is 12 meter per second along the vertical axis BC, and the time changed from t1, that is 0 seconds, to t2, that is 3 seconds along the horizontal axis OB. Now from there, you can calculate the acceleration by taking 12 meter per second, that is the final, minus the initial, that is 0 over 3 seconds, that is the final time, minus 0 seconds, that is the initial time. So you get acceleration is equal to 12 meter per second. You divide by 3 seconds, so you get the answer, that is 3 meter per second square. So therefore, the body accelerated by 4 meter per second square by changing its velocity from 0 meter per second to 12 meter per second within 3 seconds. The acceleration of the body. A body is said to accelerate when its velocity is increasing in time. So acceleration is called when a body is increasing its velocity from one point to another. That is the final velocity. Yeah, the initial will be small, so the final will be greater. And if you say the final velocity is always smaller to the initial velocity, then you get the negative, that is the deceleration, whereby we'll see it later on. See the below examples. A car starts from rest and access to a velocity of 120 meter per second in 1 minute. Calculate the acceleration of the car. Given we know that initial velocity is 0 meter per second, final velocity 120 meter per second, time taken 1 minute, that is equal to 60 seconds. So final velocity minus initial velocity, you get that you over time taken. So 120 minus 0 over 60. So you divide, you get 2 meter per second. So the acceleration of the car was 2 meter per second square. Another example, a train accelerates from 40 meter per second to 110 meter per second. What is the acceleration of the train if it changes its velocity in 14 seconds? You can calculate it simply, given that we know the initial velocity is 40 meter per second, the final is 110 meter per second. Time taken is 14 seconds. So if you substitute the values here, 110 minus 40 upon 14, you get the answer, that is 5 meter per second. So the acceleration of the train was 5 meter per second square. Now let's see the concept of retardation. So this is what we call the negative acceleration, which can be obtained when the final velocity is smaller than the initial one. So retardation of the deceleration is simply the opposite of acceleration. It is the negative acceleration. Retardation, it can be defined as the rate of decrease of velocity. So when the velocity is decreasing, maybe from point A to point B, that is what we call the retardation. The decrease, yeah, it is the decrease in velocity per unit time. A body in motion can accelerate, decelerate, or move with uniform acceleration. So those are just variables of the movements of the body in motion. It can accelerate, it can decelerate, or it can just simply move with the uniform acceleration. Uniform acceleration is when simply a body is having a constant rate of increase in velocity. So there's a constant increase in velocity of a moving body, then that is what we call the uniform acceleration. We have to note the following. When a body starts from rest or is brought to rest, its velocity is 0. And also when the velocity of the body is constant or uniform, its acceleration is also 0. And when the velocity of the moving body increases, its acceleration becomes positive. And when the velocity of the moving body decreases, its acceleration becomes negative, and that's what we call the retardation. So that's all I have for this session of That's Clear, everyone. We've discussed this acceleration. We've seen its concept. We've talked about the velocity time graph. We've seen various examples relating to velocity time graph, how you can calculate the distance, the acceleration, and we've discussed the acceleration of the body and also the retardation of the body, that is the negative acceleration of the body. Hope that's all clear, and thank you.